So, what are we going to do today?
I sent you an email with the picture. I thought I have to send it though.
Did you send it to David Cowan 1949 at Gmail?
Yeah.
Okay, because I do have another email address that takes longer to forward to me. Well, while we're waiting for that, can you verbalize any of it?
Yeah.
See if you can pick one of the problems and verbalize it, and we'll do that problem while we're waiting for your email.
Alright. So f of x equals x cubed plus 3x squared plus 25x plus 75. And you find all zeros and write the polynomial in factored form.
Okay? So, first of all, you need to notice that they're asking you to find the zeros of a cubic. They haven't taught you how to do that except by one method. What method is that?
Grouping?
Okay. When you're looking to see whether or not a cubic can be grouped, what do you look for? Can this cubic be grouped?
No.
Actually, yes. And what we're looking for is the ratio of these two coefficients, which is 1 over 3, has to be the same as the ratio of these two coefficients, which, which is 25 over 75. Okay, remember there's a 1 right there.
Yeah.
So as long as those two ratios are the same, then you can group it. If I turn that to a 74, can't do it anymore. It's a lot like quadratics. If you have nice quadratics, they factor. If you don't have nice quadratics, you have to put them into the quadratic formula. Well, there is no such thing as a cubic formula. So either we can solve this by grouping, or we have to resort to a tremendously difficult technique called the rational factor theorem, which I don't believe you've had.
No.
So we can presume the only way we can group these is like this. Now the secret is to factor out the greatest common factor in each group. What's the greatest common factor in the stuff under the left parens?
X squared.
Leaving
X plus 3.
what's the greatest common factor over here?
25.
Leaving
X plus 3.
These are always going to be the same. That's the only way they group, is if those two are the same. That's why this ratio of these coefficients has to be the same as the ratio of these coefficients, because that will ensure that you're going to end up with this. Now, this may not look like much, but you can actually, what's the greatest common factor here of this expression?
X plus 3.
Yeah, binomial. Now, for most of your life, you've factored out only monomials. What's left behind when you factor out an x plus 3?
X squared plus 25.
Okay. So, the original problem said factor it all the way down.
Yeah.
Typically, when you factor higher degree polynomials, they want it as a combination of linear factors and irreducible quadratics. Now, if this was an x squared minus 25, I could break it up into x minus 5 times x plus 5, and I would have 3 linear factors. But
Right.
I can't split up x squared plus 25. There's no zeros to that. That has imaginary solutions of plus or minus 5i. So what is typical is this would be a final answer. If they really want you to go all the way down, then it's x plus 3, and like I said, that breaks up into x minus 5i and x plus 5i. I suspect this is the answer they want.
Yeah.
Because this is called an irreducible quadratic, meaning I cannot factor it down without invoking complex numbers. Usually that's good enough. You don't usually factor higher degree polynomials all the way down to complex numbers. You factor them down to linear factors and irreducible quadratics. Well, this is called an irreducible quadratic. What else you got? You got one that has a minus sign before the last two terms? Because that needs to be treated special.
Yeah, I think the email got to you.
Okay, yeah, it did. Oops, hold on. One I'm looking for, now hold on a moment. Is this a calculator test or not? Or calculators? Are you allowed to use your calculator here?
No. Or we're not. You said we wouldn't need to.
Okay. The problem you just gave me was 6.
Yeah.
Well, that's the only easy one. Why is it number 6 is what I'm wondering. Notice that none of the other 5 lend themselves to grouping.
Yeah. I noticed that when I was trying them.
Yeah, there's ways to do these, but you have to invoke the rational factor theorem. And if you haven't had that yet, there's no way that you're supposed to be able to do that. Let me talk about that, and you tell me whether I'm way out of bounds or, oh, yeah, you actually did have it. First of all, doesn't lend itself to grouping because 3 over 27 is not equal to 25 over 8. So we can't group it. Can't factor out a greatest common factor even. There's no number that divides into everything. What's the top of this page say?
That's the actual top of the page.
Okay. Well, I'm looking at 1, 2, 3, 4. 4 has a typo. I'm sure they mean that to be x to the 4th.
Yeah.
And 5. None of those lend themselves to grouping or solving. This must be a calculator. They must allow you to use your calculator here.
Should I go grab that?
No? Because that won't do me any good. Let's graph it on Wolfram Alpha. In other words, on Wolfram Alpha, we can both see it. Whereas if you graph it on your calculator, it'll do you good, but I won't be able to participate. You know what I'm saying?
Yeah.
I won't be able to see your screen. All right, let me put this in. 3x raised to the third. You might want to do this on your calculator at the same time. It depends on whether you know how to do this. If you don't know how to do it, then you should definitely grab your calculator and let's do it.
All right. I'll be back in 1 second.
Okay.
Right.
Okay. So go to your Y1. What do you have? You have a TI-84 or an Inspire?
Inspire.
Okay. Go to your graphing page and put in that function. And you should get something that looks like that. Now you may have to play with the scale. You'll notice this scale, the x goes up to 8, but the y goes from 0 to 300. So you may have to rescale it to get anything that shows you the critical part of the function.
Yeah. All right.
Now, do you know how to find the zeros?
He's taught us, but I didn't really get that clearly.
Well, let's talk about the zeros first, because Wolfram Alpha gives them to you without needing to do anything further. We can look at the graph. Clearly there's a 0 at 8.
Yeah.
Okay, so x minus 8 is one of the roots. But notice their remaining irreducible quadratic is 3x squared minus 3x plus 1. So this should be your answer.
All right.
They do break it down and give you the complex roots on Wolfram Alpha, and here's the two complex roots. Okay. Now, what that means is that that thing doesn't hit 0. Looks like it does, but if it was touching the x-axis, maybe on yours it doesn't touch the x-axis. On mine, it appears to touch the x-axis, but if it was, it would have a real root right there. 2 imaginary roots and 1 real root means it only crosses the x-axis one time. So in reality, this root right here is not all the way up and touching the x-axis. This one is. And this is your answer.
All right.
Okay. And again, if they force you to apply the quadratic formula to that quadratic, you end up getting this, 1/6 times 3 minus root 3i, and 1/6 or 1/2 plus I root 3. So here's your two complex solutions. Now, let's go back to your Inspire. Let me pull mine out. Make sure I can figure out the zeros. Now, let's see. I have to get to graph. Let me put in this function here. 3x raised third. Sorry, I'm a little slow with these because of that Inspire's extra feature. Minus 27x squared. Minus 27x, whoops, x squared. Plus 25x plus 25x minus 8. Mine shows nothing, meaning my scale is way off, huh? So I have to hit Menu, View, Window. Let's look at Window. If I use a standard window, yeah, okay. When I put standard window in, I saw part of the graph. Now, let's see. To see the rest of the graph, what do I have to do? I have to drag it down. I'm not terribly good with, now let me go into window here, and user-defined window. Wow. Well, I'm discovering that I don't know how to use this either. Let's see. If I hit, no, I don't want that. There is a trace feature on here.
Yeah.
Let's see. Let's do view. No.
What are you trying to do?
Well, I'm trying to see the curve. I only see part of it. I can see part of it when I hit standard. In other words, if I hit 5, I see it. Now let's see. I guess I need to zoom out. Let me try to zoom out.
Or if you just go Window Settings, the first one in Window, you can just plug in what you want for the window.
Oh, that's Actions?
No, it's...
When I pull up Menu, when I'm looking at the graph and I pull up Menu, I get Actions, View, Graph, Entry. What do I want?
Yeah.
4?
So you go Menu, Window /Zoom.
Okay, that's 4. Okay.
Then you go just the first one.
Window settings. Okay, and I can set it. Okay, looks like X is. I want X to go from maybe minus 10 to plus 10, and I want Y to go from minus 500 to 500. All right. Alright, now I see it. Let's see, I need a grid. So, view with a grid, aligned grid. Okay, how do I see the X and Y axis here?
What?
Mine doesn't show my X and Y axis. Show axes. Now it does. Okay. I'm looking at basically what I'm looking on my screen now. and I can see that it's got a 0 at 8. Are you looking at it?
Yeah.
And you're seeing pretty much the same scale
Yeah.
we're looking at here? Okay. The question is does this function touch the x-axis at near 1? And the answer must be no. But let's see how we can find the zeros here. If I hit Menu, Analyze Graph, maybe? Yeah. Hit Menu number 6,
All right.
and then 1 for zeros. And they ask you for a lower bound, and all you have to really do is put your lower bound to the left of the 1 0 we know of, which is at 8. Anywhere to the left, click, and then upper bound, you have to put it to the right of 8. Hit click, enter, and it shows you the 0, 8, 0. Did yours do that?
Yeah.
Okay. Now let's see if that other thing is a 0. Let's put the thing, let's see, I guess maybe we have to hit Menu 6, 1 again. And I'm going to put the dotted line to the left of the y-axis. Hit enter. I'm going to put it to the right of 1. And hit enter. No 0 found within the specified bounds. That's good, because we didn't think there was one there. Because if there was one there, in other words, if that really does touch the x-axis, then I would have another 0. And they only gave me one real 0, 8. The other two zeros are complex. Complex zeros don't touch the x-axis. They don't go through the x-axis. So that point there is, in actuality, the peak of that curve is below the x-axis. Okay, did you figure out how to do it on your Inspire?
Yeah.
Okay, good. All right. So that's one way of doing this. Let me talk about the other, just in case this is not a calculator problem, and see if this sounds familiar at all. Stop me if it's completely unfamiliar. There is a theorem that says if this polynomial has a rational 0, then its numerator is a factor of the constant 8, and its denominator is a factor of the coefficient of the highest degree polynomial. So that would give me plus or minus 8, plus or minus 1, plus or minus 4, plus or minus 2. Those are all of the factors of 8. In the denominator, it could be plus or minus 3, plus or minus 1, all of the factors of 3. My possible rational factors are going to be plus or minus 8/3, plus or minus 1/3, plus or minus 4/3, plus or minus 2/3, and then just plus or minus 8, plus or minus 1, plus or minus 4, plus or minus 2. So these are all of my possible real zeros. And from this point, you go through and synthetically divide this polynomial by each of these possibilities until you get a 0 as a remainder. When you get a 0 as a remainder, that means that's a factor. None of these are going to work except plus 8. When I go to divide this polynomial by 8 synthetically, I will get a 0 remainder, and that will mean x minus 8 is one of my factors. And I'll also have the quadratic that's left over. In other words, if I do it here, let's just do it. We know the solution is 8. So you know synthetic division, right?
Yeah.
Okay, I'll do it real quick. Okay, we'll multiply that, add, multiply, add, multiply, we get 0. That tells us that x minus 8 is indeed one of the factors, and what's left over? This quadratic, 3x squared minus 3x plus 1. So we got our answer fairly quick, but only because I already knew 8 was the answer. In other words, had I had to do this more traditionally, I would have started with 1 and then tried minus 1, and then 2, minus 2, 4, minus 4. Finally, I would have gotten to 8, and I would have found one answer. Once you find one answer, now you're home free because you've narrowed it down to not a cubic anymore, but a linear factor and a quadratic. So, is this any way, shape, or form the way we should have done the problem?
I don't know. I've seen it before, but you didn't really explain it that well, so
Well, that's
not
because
sure.
it's extremely complicated and very, very tedious. There's no way that that's what he wanted you to do here. Why? Because each of these problems would be at least a 20-minute problem. He's given you 5 of them. So did he intend you to spend an hour and 40 minutes on your homework?
No.
No, I doubt it. Which means the more logical conclusion is they want you to answer these using your calculator. Because it gets even tougher when you get to cortex, which is this one right here. In other words, it's called the rational factor theorem. This is what I just explained to you, was the rational factor theorem and the zero remainder theorem. Those two in combination allow you to tackle cubics and cortex and quintex. But if we were doing a quartic and we found 1, 0 with this technique, we would only narrow it down to a linear factor and then a cubic. And we would have to keep doing this process, which is a very, very labor-intensive trial and error process. In other words, it would have actually taken me probably 15 minutes to find this x minus 8 solution. Just because I wouldn't have started at 8. I would have started at 1, 2, 4, and then I would have tried 8, and then I still have all these fractional possibilities. You can't ignore those. I would have had to try those also. But the beauty of this is that once I find one solution, now I'm left with a quadratic, and I can always apply the quadratic formula to that if I have to factor it further. That is another thing called an irreducible quadratic. So typically, this would be your final answer.
All right.
Okay?
Yeah.
It's difficult for me to believe that they want you to do this process on these problems. For one thing, they're all cortex except for that cubic. And that's just crazy hard. They wouldn't be giving you those kind of problems. So clearly they are calculator problems. So as long as you know how to get these into your calculator, specify the window of viewing window, and go to number 6 and choose 1, finding the zeros, you can answer these problems.
All right. So I'm probably going to need another tutor session. Like, I'm planning to do 3 tutor sessions a week.
Okay.
And I have
Let's look
times
at my schedule. What's your schedule lend itself to? When are you looking for, Mitch?
like Mondays I can do at 6.
I'll put you down for 6 on Mondays. Regularly?
Yeah.
Okay. Here, hold on a second. Let me just make sure that that's not, let's make sure that that spot is open every single week. It'll tell me if it isn't. It's got some conflicts, but not ones that are, yeah, there might be one, November 17th. Hold on a second. Yeah, somebody took that spot at 6 on Monday. 6:30 is open every single week. Does that work for you?
No.
Okay. I can do 6 this Monday, but then the next Monday it's taken, and that's the only Monday it's taken. So I can put you in there as a regular at 6 on Mondays, but we would have to do something else for the 17th.
All right, that's fine.
All right, so I'll put you in there regularly, and we'll figure out something else to do for the 17th. Otherwise, I'll talk to you Monday night at 6.
All right.
Okay, Mitch. Have a good one.